Hello, and thank you for attending my final presentation. I really appreciate you being here and taking the time out of your day. I am Sarah Axtell, the Land and Water Resiliency Intern for Western Resilience Center this fall. My project focused on ReTree site soil sampling and texture analysis in order to gain an understanding for the key factors affecting the survivability within the community's tree planting sites. A little about me before I begin my presentation. I moved to Colorado from upstate New York nearly 12 years ago now. I fell in love with the stunning mountains, natural beauty, and flora fauna this state has to offer. My dad taught me how to fly fish this summer, which has quickly become a new passion project of mine. This summer, I fell into foraging. I read The Serviceberry by Robin Wall Kimmerer and was inclined to make a serviceberry cobbler for my loved ones. It was amazing, so I'm hooked. I pull over for mushrooms, wildflowers, sheep, and geese. I love to hike and camp in Routt County, especially in Clark, where I grew up. I fell into fiber art, and I love crocheting, knitting, and spinning on my own yarn in my free time. Last but not least, I am currently pursuing my bachelor's degree in environmental science and stewardship through Colorado Mountain College. I would like to highlight my mentors who have supported me throughout this internship program. Ryan Messenger, the Watersheds Program Manager, Brenna Egan, the Natural Climate Solutions Technician, and Dakota Dolan, the Forest Projects Manager. I would also like to acknowledge the Colorado Parks and Wildlife for their dedication and assistance within ReTree programs and their efforts to restore the Yampa to their healthy and historic pathways. I would also like to acknowledge and thank CMC for allowing me to use their lab space and equipment during my jar test and soil proportion analysis. A little bit of background about ReTree before I dive right in. The Yampa River is a snowmelt-fed river that flows 250 miles west to its junction with the Green River. It is the only unobstructed, free-flowing river in Colorado. The Yampa and its adjoining riparian areas offer vital ecosystem services that are highly dependent on intact vegetation. Riparian areas aid in the sequestration of atmospheric carbon, water retention, shading rivers to lower water temperatures, and creating habitat for local wildlife. The Yampa River Forest Restoration Program was created through the collective efforts of Western Resilience Center, the City of Steamboat Springs, and the Colorado State Forest Service in response to the Streamflow Management Plan and the Yampa River Health Assessment. Over 27,000 native trees have been planted since 2010 through the Western Resilience Center ReTree projects. Over 3,000 cottonwood, willow, and alder trees have been planted since 2019 as a part of this Yampa River Forest Restoration Project. In 2025 alone, riparian restoration projects were supported by the hard work of 238 volunteers. So my main role during the ReTree projects were to set up and tear down, led volunteer groups in plantings, conducted my own mycorrhizal treatment plans, and cage correction monitoring. I would like to acknowledge Emma Hack, a 2024 fall intern with the Western Resilience Center, who laid the groundwork for my project. Emma initially sampled 7 ReTree sites and studied the impacts of nitrates, phosphorus, soil composition, quality, and texture. She highlighted the importance of expanding our soil sampling testing and evaluation. I decided to expand on protocol for my project in order to draw more definitive evidence of the major influences of survival. My project focused on collecting evidence and deciphering collected data in order to find why some sites may be impacted by low survival rates. I thought survival may have a possible connection to soil composition as well as nutrient and water availability. In my research and CMC classes, I found phosphorus was a key nutrient to cottonwood and alder health. If phosphorus is a limited nutrient, it may be indicated in diminished plant growth via reduced elongation or growth in height. Given this evidence, I wondered if this was the key to survivability. Emma Hack's analysis showed that she had come to the same conclusion as I did. Development of sampling protocol for future ReTree sites could also create a better understanding of the survival expected from the site given present conditions. My project aimed to determine the key influences of survival, analysis of soil composition and possible correlation to survivability within ReTree sites, increasing survivability and health within sites using mycorrhizal treatments, and creating practices and methodology to use for future sites to determine if the site has potential for plantings. A manual soil sample was used in order to collect soil composition data. A shovel was used to dig a hole that was about 1 to 1.5 feet across. The base of the hole was cleared of excess soil to avoid sampling false data. The cores were about 8 to 12 inches from the soil surface, and 1 to 3 random samples were taken from each planting site and mixed within a clean bucket or available bag. Soil core collection included 43 samples collected from 17 sites between Ryan, Brenna, and I. Soil samples were sent through the CSU Extension Office to be analyzed through their Servitech labs to find soil pH, excess lime, soluble salts, iron, manganese, copper, boron, a small grain test, organic matter percentage, nitrates, phosphorus, potassium, sulfur, zinc, calcium, and sodium quantity. Accessibility of the water table is also measured through a real measuring tape and a metered rod to find distance from and above the river. The CSU Extension Office soil test did not offer a soil texture option, so I chose to conduct my own within the CMC lab. The soil composition analysis, or jar test, was conducted to calculate the proportion of soil composition within a sampled site. So a little bit of background about the jar test, because I had no idea what it was before I conducted my experiment. First, I labeled the sample jars, sifted the sample with debris using a sieve, filled the jar about 3/4 of the way with soil, added a little bit of soap to separate the clay particles, add water to the neck of the jar. I shook each jar vigorously to create a homogeneous slurry and allowed the sample to sit undisturbed for stratification or layer separation. So they sat for about 5 to 7 days before analysis began. As the layers stratified, you could distinguish layers through particle size, varying colors, granule size, and they were measured manually with a ruler and a soil texture pyramid calculator, which was utilized to find the ratio of soil texture composition. I used Google Sheets to track this data and applied formulas in order to calculate the proportions. Analysis began using the Agriculture Technology Center Soil Texture Pyramid calculator and plugging in the percent of each portion of sand, silt, and clay in each sample. This is the soil pyramid calculator that we used. So another section of my project included a mycorrhizal treatment. I had no idea what mycorrhizae was for a long time. It's a kind of unique adjective or word that I had no familiarity with. So the term mycorrhizae is literally translated to mean fungus root. It's a mutually beneficial relationship between a plant and type of fungus. This underground network of fungi is an integral part of many natural ecosystems. So I conducted this mycorrhizal treatment on 2 different plots within 2 different sites in the Yampa Valley. After some research and consulting with a staff member, a little shop of growers, Ryan and I, my mentor, came to the conclusion that the mycorrhizal treatments would be, the brand to use for the mycorrhizal treatments was Great White Premium Mycorrhizae. This dry concentrate treatment was one of the highest concentrations of active mycorrhizae on the market. So this inoculation method introduces 11 species of bacteria, 2 species of trichoderma that promote pathogen resistance, and 15 species of mycorrhizae to the root system. This treatment increases, root surface volume, increases phosphorus accessibility, and improves pathogen immunity. This treatment has the potential to decrease environmental stresses that affect survival, such as drought and shock. This concentrated powder can inoculate plots using a hydroponic application. So 1 teaspoon cut with 4 gallons of water was used to treat 85 different trees. The sapling root balls were broken at the base to prevent ingrown roots and then immersed in the treatment and then put in the hole that they would be planted in. So a little bit about the results that we found using our jar test. Using the soil texture test I conducted, I was able to determine the dominant soil textures occurring across our ReTree sites was sandy loam at 46.5%, and the lowest occurring soil texture was sand at 2.3%. So using RStudio and the instruction of my mentor, Brenna Egan, we created a box and scatter graph that represents the soil composition analysis data and survival data of 31 ReTree sites. A statistical test called the one-way ANOVA test, or analysis of variance, was run by Brenna to find the significant variation within each plot. This test was meant to find the meaning of the p-value as it's indicated if the result was less or more than 0.05. The p-value is how incompatible data is with our null hypothesis, meaning the assumption that there's no difference or effect with soil composition. A low p-value of less than 0.05 indicates the results are statistically significant and unlikely to be due to chance. The p-value found by the ANOVA test was 0.97. This result indicates there is no statistical significance to indicate soil composition having an effect on survival. However, because we only were able to compare the results with 31 survival rates in sites, and so this result cannot definitively answer that soil composition has no effect on survival at all. But we also found no evidence indicating that soil composition has an effect on survival directly. The spread in our results within our data and occurrence of major outliers indicates other ecological factors that may be playing into survival as well. And although these results may not indicate definitive answer to what we wanted to investigate, it allows us to narrow in on the factors directly affecting survival deficiency and hopefully narrowing in on the CSU Extensions Office lab results and finding the factors that may influence it. So I'd like to acknowledge some statement of limitations that occurred during my testing period. Survivability rates within the same soil texture quantities could have been impacted by many ecological factors, such as lack of moisture, errors made by the planter during the transplant, pathogens, stress, pests, and shock from the environment. I could have utilized a finer sieve to filter out excess debris within soil sample jars, and this could have made defining the clay layer at the top of each jar a little easier. And all of the tests that were conducted were also subject to human error. So moving forward for Western Resilience Center. Analyzing the results from the CSU Extensions Office lab, which I just learned we received yesterday, will hopefully determine the major influences for survival. I hope these results will provide definitive evidence of the ecological factors and hopefully allow us to make changes within our plantings or maybe future soil amendments that could be implemented in ReTree sites lacking certain important nutrients. I would also advise Western Resilience Center to study the impacts of the 2 mycorrhizal treatments I implemented and continuing treatments if they are found to be successful. Other than my main 2 projects, I also took part in the Big Red Park tree planting. This was led by U.S. Forest Service in Dakota Dolan. I also welcomed and accounted for guests at the sustainability soiree. I jumped Brenda's car when it died in the field. I also took part in Western Resilience Center's first pond leveler installation alongside the local nonprofit Friends of the Yampa. This installation was conducted to lower a pond's water threshold by a few inches to prevent flooding in a family's yard during the spring. So a couple of key takeaways that I discovered during my internship. Limitations happen in the field. You have to learn and adapt, whether it's a water pump refusing to work or a soil probe that ended up not being the appropriate avenue for soil sampling. It taught me to remain flexible and well-humored about the bumps that may occur in the field. Don't let them knock you down, adapt and move forward. You can always find a solution. I continue to expand on my skills of professional communication. I learned how to collect soil samples. I learned how to conduct a soil composition analysis. I also investigated and learned how to install and create best practices for mycorrhizal treatments. I got more comfortable using Google Sheets to perform functions, and Brenna allowed me and taught me how to use RStudio for data compilation and graph creation. All right. I would like to thank Becky Edmonston from Colorado Mountain College for coordinating with me to use the lab space and equipment for my soil analysis. Thank you, Becky, for your mentorship, advice, and assistance throughout my internship experience. It's meant a lot. I'd also like to thank Nathan Stewart from Colorado Mountain College. Nathan, thank you so much for your help with systems diagramming, advice, friendly support, and lessons in phosphorus and nutrient cycling that helped me to better understand the nuances occurring within our community's ecosystems. Thank you to Courtney Lynn, also from Colorado Mountain College. for her willingness to support my soil texture analysis with lab space, equipment, and lab protocols. Thank you to my dad, Sarah Axtell, for teaching me how to jump a car. Couldn't have done it without you. Quick thanks to Billy Atkinson with Colorado Parks and Wildlife for their hard work and dedication to our community's open spaces and commitment to creating a resilient watershed in the Yampa Valley. Your expertise was greatly appreciated across the ReTree sites I was a part of. Thank you to Dakota Dolan, with Western Resilience Center, for your support, advice, and assistance throughout the soil texture analysis. I couldn't have done it without you. Your time and dedication throughout my internship term has been noticed and greatly appreciated. And thank you to my fellow interns, Olympia and Akela. I'm so happy we got to experience this together. It's been a pleasure to get to know you both. And last, but certainly not least, my staff mentors, Ryan Messenger and Brenna Egan with Western Resilience Center. Thank you both for your time, your wisdom, support, advice, and assistance throughout my internship experience. I truly enjoyed getting to know you both and learning from your expertise. I greatly appreciate and thank you for the laughs and lessons that I will carry with me into the next chapter of my career. You are both an incredible asset to Western Resilience Center. I cannot wait to see how you both will continue to contribute to your community. Thank you. Thank you so much for coming. Are there any questions? Becky.
I'm curious how you implemented the mycorrhizae, like, how are we gonna see if that's actually helpful?
Unfortunately, I think the best way we could find a definitive change would be root biomass, and I think it would be a little disappointment to dig up the trees to find the root biomass, but I think typically elongation, as in like tip growth, so height growth in the trees, and comparing them to sites that are adjacent to that plot to hopefully compare the same soil composition and avoid complicating other ecological factors. Ryan?
What was something that surprised you most or your biggest takeaway from conducting field work in restoration?
That's a good question. I definitely enjoyed being outside. That was no surprise to me. I think what was really humbling and wonderful to experience was that there's no perfect. It's a collective effort. We're all doing our best. But in the end, I think the results were probably the most surprising to find out. The fact that there is no definitive evidence of soil composition to survival was very exciting because it allows us to shift our focus to hopefully the other factors that directly affect survival rates within the results that we are going to study. Michelle?
Great job.
Thank you.
How has your experience in this internship, has it, made you discover new interests, or does it kind of shifted in what you want to do next, or just kind of open it up more personally? But how have you felt this kind of imprint on where you are now?
I'll be candid. I definitely realized I don't want to be a soil analysis technician. However, it opened my eyes to how much dedication and hard work everyone is putting into this work in my community. And it was really wonderful to be able to understand like the impact of the volunteers that help contribute to ReTree events. It could not happen without their help. So in the end, it goes back to what you said in your opening intro is we can't do this alone. We have to have many hands, many minds to contribute to the greater good.
Question, in your research, did you find any evidence that are soil better holding phosphorus these filters?
Yes, so during initial testing, I found a small correlation between soils that were dominated by loam and sand seemed to have a correlation with higher survivability. But again, unfortunately, there's no definitive evidence. But from the research that I conducted, I found that a lot of riparian areas and their vegetation do better in loamy soils. So equal portion of sand, silt, and clay.
Given your discovery about the not huge interest in continuing down that soil analysis path, what are some other transferable skills that you've developed that will serve you well in other parts of your life?
I think it was a great lesson in realistic expectations for field work. I think having to conduct the analysis and soil sampling myself alongside Ryan and Brenna was eye-opening to say the least. I think in my position at school, I would always think of field work as a beautiful, wonderful event with rose-colored glasses, I guess. Like it was something to be enjoyed, but talking with Becky at CMC, I learned a little bit more about her time in the field, and it was good to see that field work is necessary, but it's difficult work. So it was good for me to look at it in a more realistic angle. Not saying that I would not want to do field work in the future. I definitely do. I love being outside. I love being able to contribute to my community in many ways.
I have one last one, quick time.
Yeah.
So something we talk about in our work is that, of course, so you're grounded in the science and you've done the methods and the analyses. And you understand, the grounding in science, and then we talk about with people, the value of getting people out to do work together, shoulder to shoulder, taking action that's good for climate, good for building resilience. And I'm curious with your role as one of those project leaders or the group leaders with the reforestation project, would you say that we're lying when we say that, it's good for people to work shoulder to shoulder, or what did you observe when you were working with people and helping them plant trees? Just some narrative insights, do people feel comfortable? Were you helping them get comfortable with the, energy levels?
Absolutely.
Curious about your thoughts there as a crew leader.
I think it was so wonderful to be able to connect with my community on a different level than I had before. I met so many people that were so excited to be there with their kids, with their friends. I had classmates that showed up that wanted to contribute, even if it was for extra credit, they still wanted to contribute. I think it was really heartwarming. Like so many people made new connections, new friends, and everyone wanted to come together to create this better community and restore something that we couldn't do by ourselves.